So to implement the Progressive Science Initiative and Progressive Mathematics Initiative, which are the two programs of the Center for Teaching and Learning, there's two different ways of looking at this. One is how you deal with the lack of physics teachers or chemistry teachers, and the other one is how do you train all teachers in this teaching methodology, which is welcoming to everybody and successful for students, and eliminates the need for tracking, eliminates the need for textbooks, and so forth. Let me talk about the general solution first, because that's applicable to everybody. First of all, anyone can just go to www.njctl.org, so just the first letters of New Jersey Center Teaching and Learning. And if you go there, you can immediately use any of the content, and you'll find access to everything except for tests and quizzes is openly available to you. And the reason for that is it's also openly available to all students. So you can go there, use the materials. If you want to try them out, start teaching with them tomorrow, just teach with them tomorrow and see if you like them. There's no obligation. You don't have to tell us you're even doing it. If you, on the other hand, you want to see the quizzes and tests, those are also free, but we have to know you're a teacher, because if we don't know you're a teacher, you could be a student trying to get a look at your test before you take it. And so all you have to do is register, and again, it's free, and you just use your school email address, and my assistant actually checks each registration to make sure that it's a teacher, not a student. And then you have access to all the materials. And if you're really clever, you can also then go to our course on teaching the methods for using those materials and teach yourself those methods, and then you'll be more effective at understanding what we're doing. Why is it that there's a direct instruction piece, and how to use the formative assessment. Sometimes I see people, try to skip the formative assessment to save time, and they don't realize the formative assessment part is where the learning is actually happening. So you're not really saving time. Things like that we do in our training, and that's available as just slides online. We also go places and do the training, and if we show up, we can bring 20 teachers together from kindergarten through 12th grade, math and science. The methods are the same for all of our materials. So we explain how exactly, the teacher shouldn't be talking so long, how they should ask questions, how they should not answer questions, retest, the philosophy of retesting and grading and all of the things we do, why we don't grade homework, and so forth. And that's just like 2 or 3 days, depending on the background of the people. In terms of technology, because all this is done on smart interactive whiteboards or interactive projectors, and the kids all need some sort of student polling device. If the teachers are all good with all that stuff, you could do it in a couple days. Sometimes people add a third day to help teachers get better at the technology. Sometimes they add a third day so that teachers can work together in a group, because part of this process of implementation should be professional learning communities in the school, PLCs, meeting frequently to look at the materials and figure out how they want to adapt the unit plans, the presentations, and everything else to their purposes. You got Thanksgiving coming up and it's 4 days away. You want to give a test before the kids leave, or do you want to just wait until after? Those things have to be done at the school level. So we're big believers in PLCs. We're big believers in keeping everything editable so the schools can do this. That process can start at the beginning of at the end of the training, so that when the school year starts, everyone's on the same page, and then they stay on the same page through the year. Creating physics teachers takes a lot more time than that. What I just said was probably 16 to 24 hours. It's inexpensive in terms of everything, in terms of time and money, because it just doesn't take very long. To become a physics teacher, you have to learn physics as well as how to teach physics. And the way we developed the process for that is that districts will send us teachers usually, or sometimes teachers now sign up themselves. And during the summer, they take 112 and a half hours where they learn the physics course. They actually sit in the same round tables, take the same quizzes, same tests, same homework. They are the students in the class instead of the teachers in the class. And one of our teachers, very often someone who took the class before them, is the teacher, and they're in that role of the social group learning together. And at the end of that 112.5 hours, they know algebra-based physics, the first year course. In New Jersey, what happens by our laws, those teachers are then allowed to teach just that one course. So they can go to, in their school district, they can teach algebra-based physics to kids that year. And in fact, we require that they have to teach it that year. And the reason for that is twofold. One is you really don't know something until you teach it. And so that actual teaching of that course is going to cement their knowledge of what they learned in the summer. If they just learned that stuff and then went off and never taught it, they'd probably lose it very quickly. The other reason is that school districts want to switch all at once, and so they may need 15 new physics teachers for the coming year. And this allows them to send 15 teachers from any field, and that cohort then works together to learn physics in the summer. They then teach the algebra-based physics. After 112 and a half hours, we don't believe that we've taught the teachers enough that they could be given a 1,000-page physics book and a set of standards and design a course. But remember, what they're doing now is turning around and teaching exactly with the same materials, the same way. Everything's the same as what they just learned the month before. So they're turned around and teaching the same thing with the same materials. If you had to use a traditional textbook, what we're doing wouldn't work, which is why this whole paradigm shift has to happen at once. It can't be in pieces. While they're doing that, while they're teaching that first course, they then meet one night a week and every third Saturday through the school year. So they have another 187 and a half hours of instruction, so 300 hours of classroom instruction. At the end, and that allows them to, when they're meeting weekly, to not only learn new physics, so they learn trigonometry-based physics, they also meet together as a cohort to talk about what they didn't understand of the physics they were teaching, what they worried about in the physics they're going to teach the next week, practice problems with methodology, teaching and learning methodology. All of that they can do as a PLC, not within the school, but now with just the physics teachers from across the district or even across multiple districts. So that process of teaching and learning, where the teachers learn or are in the role of the students, and then they transfer what they've learned as students to other students, is what makes all of this work. It's like a chain reaction where each group then teaches the next group and allows for exponential growth, because the teachers who are learning it this year can teach other teachers the next year. That's the same thing that really does happen with the methodology too. We don't usually have to go back to schools after this is established, because teaching and learning this way is much easier than teaching and learning the traditional way. And kids like it better, teachers like it better, they don't go back, and the new teacher comes in. It doesn't take very long for the teachers in the school to bring the new teacher up to speed on how to teach this way. Thank you.